So, hello friends. Today we are going to solve Leetcode 2598 and actually I'm excited to explain you this question because there are some topics that I like it. I personally love those topics. Okay. So, without wasting any time, let's start. So, you are given an indexed 0 integer array nums and an integer value. In one operation, you can add or subtract value from any element of nums. For example, if nums is equal to 1, 2, 3, and value is equal to 2, you can choose to subtract value from nums 0 to make nums is equal to minus 1, 2, 3. So basically, you subtracted 2 from 1 and you got minus 1. Max of an array is the smallest missing non-negative integer. So if you don't know about this, you can just go to Wikipedia because I don't want to waste any time. And this is self-explanatory. Okay, you can just understand by this statement also. Examples are also given. Return the maximum max of nums after applying the mentioned operation any number of times. Okay, so I'm gonna open my whiteboard. Wait a bit. Yeah, so I hope my whiteboard is visible. And let me change the background to black color. Yeah, this is nice. And color of pen as red. Okay. So let's take the example 1 minus 10, 7, 13, 6, 8. 7, 13, 6, 8. So what is the max you can create? Okay, maximum max that you can create in this array. So our value is equal to 5. Okay. Can I add 5 to this one? Of course, I can do it. I can add all multiples of 5 or subtract all multiples of 5 to this number. For example, I can do 1 minus 5 or 1 minus 10. But wait a bit. Is it necessary? What is max? It's minimum excluded non-negative integer. So why the hell you would want to make it negative? You would not do it. So I want to make every number positive. So this is what I get. So 1 minus 5 is negative. So there's no point of doing this. Okay, 1 plus 5, we can do 1 plus 10, 1 plus 15. So these all are nothing but multiples of 5. 5 into 1, 5 into 2, 5 into 3. And you can get these numbers. Similarly, minus 10, it's negative. So you would want to make it positive. Okay. So, okay. First, just do hidden trial and try to find what is the max in this array. This is 1. I will want this number to remain as 1. We have minus 10. So I can add plus 10 to it. Okay. 5 into 2, which is a multiple of 5. I will add 5 two times. So minus 10 plus 5 plus 5. We got 0. So this is 0. Then 7. I can subtract 5 from 7. 7 minus 5. I got 2. So you can see 0. We have 1. We have 2. Then 13. 13 minus 10 is 3. So what I can do, 13 minus 5, which is nothing but 3. 6 minus 5 is equal to 1, but we already have 1. So okay, no need. And 6 plus 5 is equal to 11. Also no need. 8 minus 5 is equal to 3. So okay, 8 minus 5 is equal to 3, so you make it 3. 6 minus 5 is equal to 1, so you make it 1. Okay. So we were able to make 1, 0, 2, 3, 1, 3. Or if you just sort it, well, sorting is not required, but you can see from here only 0, 1, 2, 3. So minimum excluded number is 4 here. You have 4 not present in the array. So what was our max? In this case, it's 4. This is first thing. Now, second thing. In the constraints, it's written that value of nums I can be up till 1e9. And this is a large number. But size of num is maximum, it's 1e5. Now I'm going to tell you a very important thing. Maximum, just keep this in your mind forever. Okay, if you're doing competitive programming or DSA forever, then keep this thing in your mind forever. So maximum max of an array can be can not be more than its size. And what I mean, let's say n is the size of nums array. So n can be the maximum value of max. That's what I'm trying to say. And why? Why I'm saying how I am claiming this statement. Let's say that there were some elements A, B, C up till, let's say, Z, Z, Z. Okay. And its size was n. So in this array, you will have to find 1, 0. You will have to find 1, 1. You will have to find 1, 2. Okay. And up till, if you go up till n minus 1. Okay. So how many elements are these? From 0, 1, 2, 3, all are continuous. So how many elements are these? These are n elements. And you can fill n elements in this array only. In this array, you can fill only n elements. Okay. So what is your max in this case? N only. It's n. N cannot be present. You cannot fill 0, 1, 2, 3, 4, 5, 6 up till n. You cannot fill. Then the size will be n plus 1. So if the size is n, then maximum max you can get is n only. That's what I'm trying to explain you. And I think you understand this. Now let's just go to the problem, how we can approach the problem. So we are given a value, okay, and using this thing we have to find the maximum max. So let's go to this test case. 1 minus 10 7 13 6 8. So we have 1 minus 10 7 13 6 8. So whatever we were trying to do, it was nothing but a hit and trial, and we cannot just code hit and trial. We cannot. Okay. So how can we approach this? There's an intelligent observation in this problem. Let's say in this case value was 5. So I do calculate remainder of all nums I. Okay, nums I percent value. What I'm trying to say is nums I percent value. I'm trying to find what number will we get if we divide nums I by 5. Okay, not nums I by 5. What value will we get if we divide nums I by 5, and the remainder that is remaining, what will be that value? I'm trying to find that thing. So in this case, 1% 5, it's 5. Minus 10% 5, it's 0. 7% 5, it's 2. Okay, sorry, it was 1. Sorry, my bad. 13% 5, it's 3. 6% 5, it's 1. And 8% 5, it's 3. Okay. Now, this is all you need. Trust me. Let me ask you one thing. if you have some array, let's say you have 0, 1, 2, 3, 4. Okay, and I'm considering that value is equal to 5, which means I can add 5 or subtract 5 from this number. Then again you have 0, 1, 2, 3, 4. Again you have 0, 1, 2, 3, 4. Again you have 0, 1, 2, 3, 4. Then I can just see this array and I can tell that max of this array is nothing but 20. I can see it. Now I'm going to tell you how. See, this is 0, 1, 2, 3, 4. I will leave this number as it is. Then I will add a 5 here. I will add a 5 here. I will add a 5 here. 5, 5, 5, 5. And I will get a 0 plus 5. It's 5. 1 plus 5. It's 6. 2 plus 5. It's 7. 3 plus 5. It's 8. 4 plus 5. It's 9. And then this now I will leave these elements as it is. Now I will add 2 times 5 here. 0 plus 2 times 5, it's 10. So I'm going to add 10 in this group. 0 plus 10, 10. 1 plus 10, 11. 2 plus 10, 12. 3 plus 10, 13. 4 plus 10, 14. Now I'm going to add 15. 5 plus 5 plus 5. Okay, this group is done. Now I'm going to this group. 0 plus 15 is 15, then 16, 17, 18, 19. So you are able to go up till 19. So what is the max? It's 20. Okay. So this is one thing that I told, and I think this is a big hint of this problem. Now, I want to tell you one more thing. Let's say that it was 0, 1, 2, 3, then 0, 1, 2, 3. Then again 0, 1, 2, 3, but value was only value was 5. Okay, 0, 1, 2, 3. Then again, okay, 0, 1, 2, 3. I'm making 4 groups. Then by seeing this array, I am not saying that my max is 20, okay, or 16, because 0 the size is 16. So I'm not saying the max is 16, because you just leave this as it is, 0, 1, 2, 3. Then you will add 5. You cannot add 4. So 4, you could not make 4. So 4 is the max. Max is equal to 4 in this case. So what I'm trying to say is, let's say you had your array nums, you had some elements, you calculated nums I percent, you had another vector temp, and in this temp vector you stored nums I percent value. Okay, you stored this value. You stored this thing is this temp array. Now you will go from 0 up till 1e5, because this is the maximum size. So you don't need to go beyond this. Okay. And you will find first value not present in this temp array. Okay. We are not iterating this nums array. We just transform our nums array. And now after the transformation, we are trying to find the first value which was not present. So in this, the first value was not, which was not present was 4, which is not equal to value. So if first present element is not equal to value, then I will just say that that is my answer. So not present, first not present element, if it's less than value, then I will just return not present. Okay. But if my first not present value equals to value, equals to value, then it's a different scenario. Okay. And one more thing, first not present value cannot go beyond this thing, cannot go beyond value. It means that if value was 5, then first not value cannot be 6. It's impossible. How? Because we are creating this remainders. Okay. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay. In this case, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So first not present value will be 5 maximum. It cannot go 6. Okay. When you reach 5, you will just say, yeah, this is not present and this will be your max. Not max, but this will be your not first not present element. Okay. So in this thing, अब इसे कैसे कर सकते हैं हम? Let's check. So this is very much clear, I guess. If not present value is less than value, just you just return not present. But if it's equals to value, then how you go about it? You just check this thing 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, and then 0, 1, 2. Let's say this thing. Okay, so first I will try to find. So we know this thing of for sure that if not present first not present value is value, then last present value was value minus 1. Okay, last present value was nothing but value minus 1. Okay, this is normal aptitude. You got it? Now I will iterate from I is equal to 0 to last present value. Last present value I plus plus, and I will find minimum occurrence of 0 till last present value. So what is the occurrence of 0 in this case? 0, 1, 2, 3. So first 0, second 0, third 0, fourth 0. So 0 comes 4 times. Now one, first one, second one, third one, and fourth one. 1 also comes 4 times. Similarly, 2 also comes 4 times, but 3 comes 3 times. Again, then 4 comes 3 times. So in these occurrences, I will have minimum occurrences, which number comes minimum number of times. So 3 and 4 comes minimum number of times. So my minimum occurrences is nothing but 3. So you know what this means? That we can make 3 complete rounds. And after that, you will not have 0, 1, 2, 3, 4 again. What it means is 0, 1, 2, 3, 4, one complete round, then 0, 1, 2, 3, 4, another complete round, then 0, 1, 2, 3, 4, another complete round. Okay. This minimum occurrences tells us this thing. So if you have 3 complete rounds, so what's your max up till now? It's value into minimum occurrences. Okay, value is 5. 5 into 3, 15. So 15, you got it. How it's 15? 0, 1, 2, 3, you 3, 4, you leave it as it is. Then 0 plus 5, 1 plus 5, 2 plus 5, 3 plus 5, 4 plus 5. It's so it will become 9. Then 0 plus 10, 1 plus 10, 2 plus 10, 3 plus 10, 4 plus 10. It will become 14. So up till now, 14 is the last value. So minimum max is 15 up till now. Now you will check that how many so one more complete round cannot be made, but there might be some values which are which you can still make. Like in this case, 0 plus 15 is 15. It will become 16. Then it will become 17. So yeah, you got it. What I'm trying to say. Okay. So in this case, your max is 18. Max is equal to 18 in this case. Okay. So how we are gonna find this? See, first I will calculate minimum occurrences from 0 to last present value. Okay, I will find minimum occurrences. Then I will find my max. Up till now, my max will be value into minimum number of occurrences. So my current max is nothing but 15. Okay. Then what was my minimum occurrences? Can I say this value as number of rounds? It's same. Okay. So now I will check. I will again go from 0 to last present value. Okay. And then I will check if occurrences of I is greater than number of rounds, max plus plus. What I'm trying to say, because if it is greater than number of rounds, so it means that after you complete 3 rounds, it was that number came again. Okay, and we are going in sequence. So we will go as from 0, then 1, 2, 3, 4. Then again, I will check if its occurrences is greater than number of rounds, which is 3, and its occurrence of 0 is 4. So yeah, after completing 3 rounds, this is coming again. So my max will be max plus plus. So my max becomes 16. Then I will check for this also. Its occurrence is also greater than number of rounds. So my max increases again 17. Then for this also, my max its occurrences is greater than number of rounds, which is 4. Okay, so my max increases again 18. But when we come to 3, its occurrences is 3, which is not greater than the number of rounds. It means that after completing 3 rounds, this number was not present and we stop at this. Okay, this was the whole solution. Now I'm going to show you the code and it will be easy. So this is the code. Okay, so don't go, if you can implement it better than me, it's even better because I'm not sure about my implementation skills. I created a stem vector, then this was my size and my vector size. Okay, then this I initialize this sets maps to count occurrences. Okay, this is to just check the first not present value, to check first not present value. Then this is my transformation, nothing but I'm just transforming my array. Then I'm going to find my first not present value. Okay, I go from 0 up till 1e5 because I know that maximum size of nums is 1e5. So maximum not present value can be up till 1e5. Okay, which can be my max. Okay. So from 0 to 1e5, I iterate. Check if it's not present. If I is not present, I just store it in my not present variable and just break it. Okay, this was nothing. It was just debugging. Just close it. If not present equals value. Okay. And what if it's not? Then I just return not present. I just told you. Okay. You remember? If it's less than value, first not present value is less than value, then you cannot even complete one round. So how you can jump to other round? Okay. And when I see this, then I will say another round. Yeah, you have to make another round. Then my present till not present -1. If not present equals value, then up till which value it was present? Not present -1. Okay. Then my num rounds. Okay. So initially I am initializing my num rounds as 2e5 because I want to calculate minimum occurrences. You remember that? From 0 up till present till I just calculate my minimum occurrences of each value. Okay. So you get your max as num rounds into value. Okay. This is your current max. And now after calculating current max, you again go from 0 to present till. And you don't need to go to present till. You can even go to present till -1 because if again if you are able to reach this present till again, then it's included in your num rounds only. Okay. I hope you are understanding. If it was this that you are able to reach this percentile, then my num rounds would be just increased by 1, and again this thing would not be required. So we go from I0 to 0 up till present till -1, and if occurrence of this thing is greater than num rounds. It means after completing num rounds, which can be 3, 4, 5, or any random number, this is coming again. So your max is increased. And if that number didn't come, then from that point, that particular point, you will stop and return your max. That's all. So this was the whole solution. I hope you can understand the problem. So that was all from my side. Let me just end the meeting. Okay.